Good morning, everyone. Ted Cross here with Novi Labs. Appreciate everyone showing up today. Really excited to have everyone here for our webinar on optimizing oil and gas cube developments with machine learning. First thing, we're going to take a few minutes to go through some basic kind of housekeeping items. We'll do some introductions for the team here with Novi, and then we'll get to the content. So thanks everyone for showing up. First off, we have the chat running. You see I've already kind of dropped in some comments there that will be starting at 11:02, which is right now. We'll be dropping kind of resources, links from time to time into the chat there, kind of depending on how things are going that may kind of help understand certain items. We're also going to have a questions and answer period. That's going to be moderated by our panelist, Kieran here, who will introduce himself here in a minute. He'll be answering some questions live during the webinar, and some we'll save for the end that kind of John and I will be handling when we get to that point. You can ask those. You see there's a little Q&A tab, and then you can kind of see which ones of those have been answered or which ones he's answering via text. Okay, so that's the main housekeeping items there. Next thing, we'll just introduce who you're going to hear from today from Novi Labs. I'll go ahead and start. My name is Ted Cross. I'm a technical advisor with Novi Labs. My background is actually as a geologist. I worked for ConocoPhillips for around 5 years. Very happy to see a few of my former coworkers in the attendees list there. So good to see you all. And I've done a variety of development roles, exploration, et cetera, and been at Novi for 2 years now, working as a technical advisor. John, you want to go ahead and introduce yourself?
Sure thing, Ted. John Ludwig here. I'm the original founder of Novi. Started the company back in 2014, 2015 timeframe. Worked in the industry prior to that, and I'll just be providing a little color commentary during the session today as a panelist.
Okay, Kieran?
Kieran Sate, former geophysicist, data scientist, and now work in technical sales for Novi. And I'll be running the chat window here. So if I don't respond to your question in the chat window, don't get mad at me. It's so good that we're saving it to talk about it later.
That's a good point. Okay, Kieran, John, thank you guys for your introductions there. We're going to go ahead and get into the content here, and we'll start with just kind of a top level agenda. So first, we're going to go into an introduction about the cube's spotty history and why operators are interested in it again today. We'll then cover recent cube design trends, taking the Midland Basin as our case study there. We'll then discuss the challenge of why it's so hard to analyze and plan cubes. And then we'll hit the solution, which is how machine learning can help for cube optimization problems. So that's what we have planned for you all today. Very excited. Of course, please put questions in the Q&A and any other comments in the chat. Thank you. Okay, so many of you are probably familiar with the cube from 2017, 2018, 2019 timeframe, when there was this idea percolating around that operators could avoid parent-child interactions by co-developing their wells. They could develop many zones in order to maximize the recovery of a three-dimensional volume of rock. They could get lots of operational efficiencies with these sort of large-scale developments, by having multiple frac crews on site, let's say, or by building these kind of mega pads, save on pad construction costs, those sorts of items. And all of those could roll up together to support extreme densities. And so we've grabbed over here on the left, you see a few examples of some just investor relations slides from back in the day, kind of around this vintage where, these operators were kind of suggesting that they might be able to hit 40, 50, 60, maybe even 70 wells per section. That's wells within a given square mile for any of our international attendees here, which is, of course, incredibly dense by kind of our standards here of 2021. And these incredible densities kind of propped up a lot of dreams of these investor relations decks. When acreage was being bought or sold, a lot of times the promise would be that, hey, maybe you could support this level of density. And so this was why the cube was such a hyped idea back in the day. And if you want to go dig into it a little bit further, I can share you some more resources on that. But very exciting idea from that time in the industry's history. So what kind of happened with the cube? This is a stock chart of a prominent Permian Basin operator. And you see they're kind of chugging along, $100, $150 range for their stock price. And then in August of 2019, they had a very dense development test that they were running. They announced the results of that test, and the stock price cratered. And various operators had a similar story to this where, hey, maybe their oil production came in a little bit low, maybe their gas production came in a little bit high. But the moral of the story is that this kind of dreams of those investor relation decks of these 50, 60 wells per section, that clearly it wasn't actually going to be a solution for that problem. So that's what was going on with the cube. But this is actually something that we've been hearing a lot recently when we've been on the road talking to prospects, talking to customers. The kind of dream of the cube is in some degree back. And so for now, I'm going to pass it over to founder John Ludwig here to kind of discuss why we should still care about this.
Yeah, thank you, Ted. So why do we still care as a constituency, as an industry? There's really four main things that are still pretty critical about getting cube designs right. The first, which is purely financial, it's still the key to driving net asset value and cash flow. And so if you go too aggressive, too many wells per section, as Ted just mentioned before, obviously you lose cash flow, subtract net asset value, and as you saw from that chart, if you're public, you can subtract a good amount of company value as well. But if you're not aggressive enough, you leave value on the table, net asset value, cash flow, et cetera. So it's still critical to get this right. The second thing, this is also related to driving increased value. We're seeing a lot of customers interested, and I'm going to steal this because a customer actually used this term, but surgical strikes. So getting cubes right is not all about a co-developed cube in greenfield acreage. The surgical strike, as we've defined it, is, well, what if I put a lease line well between these two existing developments? Or what if I've just acquired acreage in a very developed play like Eagle Ford or Bakken? How do I improve the net asset value? How do I bring learnings, completion designs, et cetera, offset well interference? How do I bring that in and actually improve net asset value by figuring out where you could still develop generate positive net asset value and cash flow. And then courtesy of all this cube development that has occurred, there's a lot of data. That's a huge advantage. We know now what good and bad look like. Ted's going to show you a bunch of examples of good and bad and how cubes have sort of changed over time, but every single cube that's been developed has left a signature. We can all benefit from that if we know how to use the data well. And then the last thing is what we found in our work, machine learning models can tease out these subtle warnings from the past. And they can also, if applied correctly, they can also explain their work. What I mean by explain their work is if a model forecasts X or Y for two different forms of a particular cube design, can it tell me also why? Because answering why is really important when you're making the kinds of investment decisions that the industry is being asked to make. So the sophistication of the models is not just the ability to make accurate forecasts, it's also the ability to explain their work. And those two things together are critical for any kind of value case or financial case to continue to develop cubes. So those are few of the things that we're hearing from customers today, and a few of the problems that we're working on developing solutions for here at Novi. So with that, I'll go ahead and turn it back to Ted.
Great, thank you, John. Good insights there. So for today's webinar, we want to kind of set some groundwork for who this is for, what is a cube, et cetera. Just because, the idea of a 70 well super development is dead doesn't mean that the concept can't still be useful. So we're going to kind of use cube to refer to any multi-zone development with over 15 wells per section. Those can still be three-dimensional, of course. And so this is a little bit broader than historically in the 2018, 2019 range, what people were thinking of as a cube. So just keep that in mind as we're going through the rest of the day. The other thing is that this is going to be a subsurface focus. So we're not going to be covering kind of how machine learning can optimize your simultaneous operations or any pad construction innovations or anything like that. This is about the reservoir. So, executives, reservoir engineers, geologists, et cetera, completions engineers, production engineers, a lot of them will get some good value out of today's webinar. So we're going to go ahead and start with a poll just so we can learn a little bit about our audience that we have here. And this is just simply about your development planning goals. So we want to learn kind of what is interesting you all most right now. Obviously, we kind of know what we hear about from our customers, but want to just get some ideas from a little bit of a broader cross section like what we have in the audience here today. All right, seeing a lot of votes come in. Okay. Let's see. See if we get a few more stragglers in there. Looks like cube optimization is winning a little bit neck and neck. All right, looks like we're starting to taper there. So let me go ahead and end the poll. So, all right, we saw half of you said cube optimization. That should be no surprise given what we're in today. Of course, completion design still being something that operators are interested in. Let me share the results. Thank you. All right, cube optimization number one there, 50%, completions, 31%. Delineation, not quite as big of a deal for the industry anymore. And still people out there thinking about surviving with leaner staff. Yeah, these are common things that we hear. It just kind of depends on, customer to customer, operator to operator who we're talking about. But thanks you all for filling that out. Okay, so now we're going to get into some recent trends in cube design. And part of the reason we're going to cover this is just kind of the basic concept that, the cube design, the cube hasn't really died. So again, here we're going with multi-zone developments greater than 15 wells per section. What I'm going to show you is for the Midland Basin, this is in West Texas, for kind of the main counties here, Martin, Howard, Midland, Glasscock, Upton, Reagan, Irion. We're going to step through some example cubes that operators drilled through the years. So, and these are per square mile equivalent. So some of these down here in Reagan County, it might have been, six wells and kind of like a little mini cube covering a third of their acreage. In 2015, we see that their operators really start to kick in and start developing those cubes, and that it's kind of following the general Midland Basin trend away from that southeastern part of the play into that kind of northwestern Midland Martin County. If we step forward to 2017, we see kind of the migration of those dense developments continues out to even Howard County, further into Upton County, as operators are kind of experimenting more and more with these developments. And then if we look at a 2019, we see that the majority is kind of taken place in kind of where today the densest developments are concentrated, which is Midland County, Martin County, and Howard County. So some of what we want to say here is that, number one, cubes are still, people are still going to town on dense developments, even if they're not, 60 wells per section, but also that, the industry has taken a little bit of time to figure out what geology actually kind of supports these. And in continuation of that, getting a little bit more granular on the details here of these developments, we have the kind of effective wells per section here on the y-axis of each of these box plots. So that's I've just taken the number of wells within a given development and scaled it up to normalize it to one square mile developments or one section. So a third of a section, half test, just multiply it by 3. So here we have Howard County, Martin County, Midland County, and Reagan County. And we see that like what we saw previously on the slide, kind of Reagan County, there's some earlier denser tests. Operators maybe kind of figure out that that's not really supported by the geology there, and we start to see the kind of cube density drop off. Whereas for Martin County, Howard County, Midland County, those dense developments have continued all the way through 2020. So, despite what you might have remembered from the headlines back in the day, there's still very much dense development going on out there by operators today. One of the key trends that we've seen, and this, if you remember back to kind of our key items for the cube, is the number of zones that are being developed. And so what we have here, these are box plots of the number of zones developed in any given cube going from 2013 out to 2020. We see the average, goes from 1.6, 2.6 to today, it's at about 3.5 zones per cube. So that concept of the cube that you can spread that density across multiple zones is still definitely something that operators are employing across the Midland Basin today. One other interesting thing that we've seen when we've been analyzing these developments is also a trend towards staggered developments rather than stacked developments. So what I mean by that, if you see that top little gun barrel plot over there on the right, we see all the wells are stacked on top of each other. The bottom plot, we see a staggered development where that middle zone is kind of offset into the middle of the top and the bottom zones. So when we're doing our spacing calculations, we will kind of measure the distances both to that lateral neighbor and to that staggered neighbor within any given development. And we can actually use the ratio of those to quantify to what extent it's a stacked versus a staggered development. So a 1 of equal distances in the XY space would be a perfectly stacked development, and a 0.5 would be a perfectly staggered development there. And we see essentially back in 2015, 2016, equal populations of stacked and staggered developments. And then through time, as we go out to 2020, we see that becoming almost exclusively a staggered development. The stack is kind of starting to disappear or kind of go extinct out there in the Midland Basin. This is also something that we hear about our customers thinking through these types of items as well. Another big kind of idea or concept from the cube was the co-development versus parent-child. And so when we look across the entire basin, in red here, we have a parent-child style developments, and in blue, we have co-developed. We see that the share of co-developed cubes through time, and it started off in kind of in that 2016 they were 10 to 20% range. Now over 50% are co-developed, and you can kind of imagine that if the operators weren't forced into parent-child based on what they had drilled previously for kind of their parent wells, maybe they had to hold it by production, maybe they just kind of hadn't learned the lesson. It was something they drilled back in 2013, 2014, but some huge share is coming in as co-developed. So even though kind of the dream of the cube is dead, a lot of concepts are still alive and well there. Okay, so next we're going to switch gears and cover a bit of the challenge, and this is why it's hard to analyze and plan cube designs. So for this one, I'm going to pass it back to John again to hit some of the challenges in cube development.
Thank you, Ted. And I'll just kind of go in order here from left to right. I mean, first of all, the problem is a highly dimensional problem, and some of the dimensions don't exist. So you have to actually have some way of creating them. So the first, lateral, staggered, and stacked neighbors. So what is a staggered neighbor? How do you define that? What is a stacked neighbor? How do you define that? How do you measure all those distances? So those don't exist anywhere. So you either have to license those data sets or create them on your own. And then in addition to just the raw distances, there's timing. So what exactly defines a co-developed well versus a well that's parent-child? And how does one configure that and make that decision as you're building the data sets you're going to use to analyze the problem? Next thing, calculating the required attributes for a large-scale basin-wide data set. So if you have a method to do these timing and distance calculations, you need to be able to do that for all the wells in a data set, so you can include as many examples of cubes as possible. And then the thing that we found that's really important is that users need to be able to make these decisions. What is the cutoff between parent-child? That should be something that is configured as an example. Or what is the aperture or angle of aperture that I look for staggered neighbors? Is it 20 degrees from an existing well, 30 degrees, et cetera, et cetera? So it's not just the dimensionality of the problem, it's also the requirement to be able to configure these calculations on a data set by data set basis. The next major thing is what we call subsurface driven data starvation. So you really want to learn from as many cubes as possible so you can absorb those lessons and utilize them in your own development plan. So in order to learn from as many cubes as possible, you need a large scale regional subsurface data set like the one you see in the picture above there. What we find is that most operators have strong subsurface characterization in their local area, but they have limited coverage available outside of that. So there are data sets you can license for this purpose. That's been a major focus for us here at Novi, is so that we can allow customers to include as many examples of cube developments as possible. The next thing that makes it challenging is if you've built any kind of data-driven model, you want to use that model then to actually make forecasts and run scenarios for various ways you might develop your acreage. So it could be a surgical strike lease line well, or it could be a co-developed cube, or it could be you want to look at maybe coming in underneath an existing development that was done several years ago. So you want to run all these scenarios and look at different ways to allocate your capital. In order to do that, you need to have dynamic parent-child calculations for these hypothetical developments. So if you're going to plan a cube where you're going to come in underneath an existing development, you need data that gets generated on the fly that describes distances, timing, et cetera, and allows your whatever method you're using for modeling to change the forecast based upon those factors. The other thing that's really important is whatever method you're using to make forecasts or predictions, it needs to be output in a time series. So we learned early on that making a point prediction at say IP360 or IP720 only is valuable and useful, but it's not nearly as useful as showing the shape of the curve and how the production rates change over time. Because one of the things that we've seen is examples of tightly spaced cube developments going gassy, so you'll observe the gores going up over time, and understanding that in advance is really, really critical. So that's one of the problems that we've chosen to tackle here at Novi, is making sure that when we output a forecast, we're doing it in a time series way so that customers can actually see these changes in curve shape. And the last, which I mentioned a little bit earlier, is explainability. So you really need to be able to have the model not only output a forecast, but also output something that explains why that forecast was made. What variables, down to the individual well level in a particular cube, what variables are driving that forecast? So we've tackled that problem as well, because we believe that explaining these forecasts is almost as important as the ability to make the forecast itself. So those are all challenges you got to tackle if you're using any kind of data-driven approach to assist you in the planning and engineering of your cubes. So with that, I'll turn it back over to Ted.
Great, thank you, John. Good stuff there. Okay, so next we're going to go to another poll here, and this one is going to be about actually, optimizing your asset development. So let me go ahead and launch this. While you're voting, I'm going to hit a couple items here. First, Kieran shared in the chat that we are, he shared a couple resources. Number one, he shared how our software will calculate spacing. You can go look at that data engine resource there. That's a pretty good overview of our of that product. It's very important to calculate all the data correctly. And then before that, Kieran also shared a video on the topic of the kind of parent-child versus co-development. It's kind of focused on the delay and infill strategy, and how sometimes that'll work, sometimes it won't work. Okay, still getting a few votes in here. One other little item of housekeeping as we're getting the kind of final votes in on the poll. Don't forget to put in some questions into the Q&A. Kieran is standing by, looking good in that Hawaiian shirt, ready to answer anything if it's not passed to us there at kind of the end of the presentation. Okay, looks like we're getting a pretty good set of votes in there now. So I'm going to go ahead and close it and share our results. Okay, so we see data quality kind of winning the poll, or maybe losing the poll as it is for this one, with 41% of our votes there. Access to data being kind of the second, and then we have some other issues with aggregating, calculating spacing, and then the analytics capabilities kind of all being tied there. So yeah, I mean that's we work in oil and gas. It's kind of the reality that our data quality is not always the best, but there's things that we can do about that, and makes it a nice investment of your time if you do put that into the data quality. I mean, we've had some data quality all-stars here on the phone call. I won't call them out specifically. Okay, so now we're going to get kind of into the fun part of the presentation. We're actually going to get into machine learning for cube optimization, and really we're going to circle around 3 questions here: where, when, and how to implement your cube development. So those 3 kind of themes there are what we're going to be focused on. So first question, where should you actually cube? To determine what areas are kind of eligible for cube style developments, we're going to take a look at, you really need 2 things. That's one is accurate forecasts for multi-zone development. So you need to kind of know what the cube is going to produce. And the second, you need to also know how much a single zone development will produce, so that you can kind of compare whether it's actually worth the additional incremental investment for those additional zones or additional density. So we're going to step out of the PowerPoint here and go into our software to kind of analyze some of this for you live. So we're going to go into our forecast engine software here. At this point, we're kind of jumping ahead. Of course, as John has mentioned, you need to build the data sets. You need to train the machine learning models. But we're going to show you how you can use those models to actually kind of get forecasts and help you design these developments. And this is also going to show you our own thought process in terms of how this can be applied. So loading up forecast engine here. And lots of different items. We're going to step through some of these in a little bit, but first I'm just going to go to kind of the well inventories map and show you kind of how an operator might start to think about the problem. So, we'll say regional cube study. We'll call this inventory, and I'll kind of show you how these might be laid out. So let's say you're an operator in the Permian. Let's say that you have a lot of acreage kind of laid out across the play there. I'm highlighting in that yellow map. This is again our Midland Basin model. You might want to start by seeing what some cubes may produce in different parts of your acreage. So maybe you have this kind of nice chunk of acreage up here in kind of that deeper northern part of the play. So we'll drop one kind of cube in that spot of the basin. Maybe you also kind of want to see how in kind of the central part of the play where your development changes a bit. See how your production might happen down there. And then let's go down, let's grab something kind of off here on the kind of eastern fringe and just kind of see what that one's going to look like. So eastern fringe. Our customers kind of do this type of stuff a lot, but and other people we talk to, machine learning practitioners, just kind of want to drop some pads around the basin. If you wanted to be really thorough about this, you would actually kind of lay out a greater number of pads kind of all around the play. So I pulled up I'd gone through previously, it took an extra 10 or 15 minutes and just kind of laid out a larger number of pads all the way around the basin. So you see every little kind of contiguous chunk of acreage there. You see those little blue kind of little multi-zone development there, 3 zones, Lower Spraberry, Wolfcamp A, Wolfcamp B, kind of just kind of for some baselines around the basin there. Okay, so we've kind of laid out some hypothetical pads around the basin. Next step, we actually need some forecasts for those. So I'll show you kind of how that actually works. Maybe we'll get some thoughts flowing here. But regional cube baseline forecasts. Okay. So the first thing that you need to do is you need to choose a model. We're big proponents of the idea that you need multiple models for multiple purposes. Kind of our experience having done this now for, what is it, John, 7 years across every major shale play. Is that about right?
Yeah, that's about right.
Yeah. We've kind of learned the hard way, kind of what actually will kind of work for these type of problems. One thing that we will often do for cube developments and studying cubes is throw away single wells, like, or, standalone wells, like that type of stuff. We may, in the Midland Basin, a lot of times we'll remove the southeastern part of the play. But that's kind of, it'll vary a little bit, basin to basin, play to play, what exactly you're doing there. Next up, you go choose a well inventory. So I'll grab that regional 24 wells per section. Usually, if you're doing this kind of a baseline study, I would recommend that you just kind of start with something like your average completions design. So I'll grab like just a 2,000 pound per foot job, pretty close to average for the Midland Basin. The final thing that you need to configure, and this kind of gets back to John's comment about you need kind of some time series forecasting here to get an accurate result. But we'll predict, kind of depending on what play that we're in, we'll make machine learning forecasts for 2, 3, 4, 5 years, depending on the age. Of course, you want to get EURs, right? And so in order to do that, you'll need to somehow extend those out. And we use just modified ARPs, very industry standard stuff there to extend out from those point predictions. So this is, not really cube specific here, but I did just want to kind of call that out as something that needs to be done if you're using machine learning, because machine learning is data driven. Final step, and this is another very important one, is just kind of what's your confidence intervals and getting some uncertainties. So typically we'll kind of a lot of times see some P90, P10s, maybe some operators want to use like a P40, P60. Different operators will have different kind of perspectives on that. So I'm going to go ahead and kick off those forecasts here, and it'll go ahead and run those in the cloud. Definitely helpful to have a cloud database if you're running these types of things, just because 2400 forecast can take a while on your desktop. On the subject of uncertainty, Kieran just shared a link about how we actually calculate those confidence intervals. I'd recommend you check that out maybe after the webinar. Okay, so we don't actually publish any visualizations in our software. We analyze everything in Spotfire, just like most of our customers. Some use Power BI or Tableau, just kind of depends on where you're at. But what we have here on the left, I have all those different cubes that we laid out across the play. Pretty big wide chunk of acreage there. I'm just going to pull up this Bessie 1 development right here. And what I'm showing you on the right are average performance for the different zones across this Bessie 1 unit. And so we've kind of averaged, it's got 8 wells in the lower Sprayberry and 8 Wolfcamp A's and 8 Wolfcamp B's. And we forecasted each of those and then taken an average here to show you both the oil and the gas streams. The left panel shows you what it looks like as a 3-zone cube. And then on the right, we see what that would look like as a single zone development at 6 wells per section for each of those zones. An interesting thing that we see for this particular pad is that the Wolfcamp B performance degrades much more than the other zones. We're dropping from 320 or so down to 245 or so thousand barrels a 2-year cumes. Wolfcamp A and Wolfcamp and the lower Sprayberry definitely also seeing some degradation, but not to the same extent as the Wolfcamp B. And the other thing, and if any of you have actually kind of done some dense developments, you're well aware of kind of how they can go gassy, and that's definitely a concern. And we see that as the oil production is going down, our gas production is either flat or going up a little bit. So definitely something kind of depending on what you're making, at the wellhead for your gas pricing, depending on, what artificial lift type you're using, this can obviously have some huge ramifications. Okay, so next up, I'll show you just kind of, beyond just the individual pad. That was the one I just marked right there on that circle. What do my EURs look like across this full suite of pads that we have here, or units? On the left, again, we have the 3-zone developments, and on the right, we have the single zone. Right now, I'm looking at the Wolfcamp Bs. We see, and this is pretty interesting actually, some of those single zone developments, coming in at the 50 plus barrels per foot EUR, maybe 56. And these are 10,000 foot laterals, just FYI, but we've taken it in barrels per foot here. Even though those are truly excellent as a single zone development, when they're brought into a cube, they're kind of around the same or maybe even slightly worse than some of the developments over there on that kind of western, deeper part of the basin. If we look at, let's say, Wolfcamp A recoveries or Lower Sprayberry, those aren't really showing kind of that same exact trend, but definitely still some kind of spots where they're doing well in a 3-zone development or not so well. Okay, so now we have some kind of ideas of how the degradation might look kind of across these different options. We have our baseline forecast for multi-zone developments. That's kind of answering the where question. The next one, as we had it laid out, is when to cube. So this is going a little bit step further. It's not just about the forecast that you're getting, but it's also you need to weave in economics in order to screen out when it actually might make sense economically to put in one of these developments. And so that's going to be about price and cost sensitivities. So let's go ahead. We're going to kind of take one of those forecasts that we were working on previously, and we're just going to layer in a little additional information here from our economics to kind of see what it would look like under different price scenarios. So I'm just going to duplicate that one that I was working on and put economics in the title there. So we've already gone through and filled out all the different information about the basic forecast. That's pretty straightforward. Next in, we're going to layer in some economics, and this is screening level stuff, right? We're not trying to replace Aries, but you need things like a drilling cost. You need some economic conversion rules, working interest, NRIs. Those kind of basic sets of information. Discount rate, of course, is very important for a cube development. Shrinks, yields, BTU multipliers, kind of all that basic stuff. Operating expenses. This is just taken from QEP's guidance back when they were still an independently traded company. And so then, final part here is the price deck. So, for this study, I've been looking at $45 out to $65 a barrel. That feels a little pessimistic kind of compared to where things are today, but we'll just kind of stick with that 65 for now. Let's say you want to build a little breathing room into your work there. Okay, so we're gonna go ahead and kick that off same exact way as we did previously. And again, I'm going to go ahead and pull up some results for these like what we had beforehand. Okay, so now we have all those same developments, same exact kind of set of units that we had beforehand. And I'm actually going to show you what the NPVs look like for each of these. So that's what the color is. The color is corresponding to the net present value for the entirety of the unit. And an interesting thing that we see here is that single zone developments, of course, for the most part, are winning the net present value maximization at $45 a barrel. And this is just because a lot of those multi-zone developments aren't doing so hot with really aren't even breaking even on an individual basis. So even though you're getting a lot more inventory by going to that multi-zone development, you may kind of barely be breaking even or kind of even going negative on those developments. And everything that I'm showing you here, this is unburdened, no corporate G&A put into here, it's all pre-tax. So, kind of optimistic compared to what your internal numbers may be. But we do still see there are some units like, let's say the maybe unit up here in the, let me highlight that, up in the northwestern part of the play. Unit 8 and unit 5 on that development are still looking really nice for a multi-zone development at $45. If we kind of switch it up and look at the maximization of the NPV for a multi-zone development, or look at maximization NPV at $65, we see that that's kind of dominated by a lot of these multi-zone developments. So you've seen a lot more of those kind of 3-zone 24 wells per section rising to the top. And then if you look over there on the left, there's a lot more green on the map. Of course, this is not rocket science here. A lot of the art of this is kind of figuring out exactly, kind of depending on, for your given preferred economic metric, for your own internal price decks, for the amount of budget, your cost of capital, et cetera. There are a lot of levers to turn here. But once you actually have these different development scenarios, for a huge area, like you can generate very quickly with machine learning, it's much easier to kind of layer in these additional economic elements there. Okay. So let's go ahead and switch gears. We've covered that. That's pretty basic win there, but we're going to hit some more details here when we get very specific. So now we've done where, we've done when, now we're going to do how. And for this, we're going to focus in on a specific area for the cube development. We're going to dial in some details, like what spacing am I going to use? What completion design am I going to use? We'll look at some different price decks, some different completion costs, and see how those can influence what I end up doing with my development. Okay, so if you remember from the what I was just showing you, we had one particular unit up there in that kind of Martin Andrews area, county line area in the northwestern part of the play that was looking really good. That's the maybe kind of, I think it's probably the maybe ranch, but the kind of maybe units, judging based on the other kind of unit well names up in that area, and it looked really good on our forecast there. So I've gone ahead and laid out at 18 wells per section here rather than 24 across the play there. One thing that we do in our software that's important, that anytime you're using machine learning or anything else for one of these, you have to be able to calculate the parent-child relationships when you actually go to implement this. So you see, for instance, in this little unit up here, there is an existing Wolfcamp B development. On either side, you have some Wolfcamp A, Wolfcamp B, Lower Sprayberries on the kind of eastern side of the pad, and on the western side, you still have a couple other developments there. So what our software will do is it'll go through and it'll calculate all these relationships. It'll see how long these wells have been on with respect to the kind of infills that you're putting in. It'll calculate all the spacing within this scenario and with respect to everything else. FYI, if I wanted to kind of see what these would look like at a different development density, let's say I want to grab these three, pretty easy to do. Just go hit that little replace button there and kind of swap it in if I wanted to see what it would look like at, let's say 36 wells per section or something dense like that. Okay, see the denser ones dropping in there. So it's important to be able to do all this pretty quickly. So we ran some scenarios at 18, 24, and 36 wells per section. I also kind of just want to show you, you need to get your templates dialed in for that. So let me pull up our 18 wells per section one here. So this is what I used. I skipped over this beforehand, but use this to kind of lay out our developments. This is just a 3-zone 18 wells per section. We've got 6, 12, 18. And then we have these kind of defined by their densities here. So we have, 880 spacing for the Lower Sprayberry. If I wanted to add in, some Dean wells here, 13, 20 feet or whatever it is, you can put that into the software. If I wanted to try these out on a stack development rather than a stagger, I can also define that there in the software. But these kind of 36, 18, 24, that's what we have kind of for this study. So now I'm going to again hop back into Spotfire and show you some of the results of our study of that maybe acreage. So just like before, we have hundreds of forecasts here, along with our confidence intervals for different developments across this piece of acreage here. We see our confidence intervals are varying. We kind of see our forecasts are varying both for oil and for gas, kind of depending on where you are. So remember, we're trying to understand the how development. So we're going to look at a couple items, and let me go ahead and bring up a visualization of how our forecasts are going to change depending on the development density and the completions design and the formation. So what I've done here is I've just taken our average forecasted 2-year cumulative production, and I'm showing those for different densities. So each panel that you see on the top, single zone, 18, 24, 36 wells per section, those are our different development densities. On the x-axis, we have the proppant loading. So we're going from 1750 out to 2750 pounds per foot. And then each line that you're seeing is a different formation. So Lower Sprayberry in the orange, Wolfcamp A in the pink, Wolfcamp B in the light blue. So we see, our best zone is the Lower Sprayberry here. Our average well production would be, depending on the completion design that we use, maybe 350,000 for our 2-year cum here. If we go down to super dense multi-zone development, not only are we bringing in some individual zones that aren't looking as good, but we're also degrading the performance of our best zone. Now you're kind of looking at something maybe more in the 250,000 barrels. So it's a combination of both bringing in some zones that don't look as good as your primary development and degradation of your primary development zone. The other thing that we see is that the kind of impact of the completions intensity will vary depending on how dense your development is and which zone that you're looking at. So if you're doing a single zone development with your Lower Sprayberry, you're getting a nice 80,000 barrel uplift going from 1750 out to 2750 pounds per foot, and that's barely anything at those most dense developments. So definitely have to look at these in combination. John mentioned the dimensionality of the problem. That's one of the reasons why you want to go with a machine learning solution, is because they can handle multidimensional problems very well. So now we're going to bring in some economics, and I'll take a minute to kind of walk you through this chart. It does a great job of summarizing how you might look at one of these developments. So on the top, what we have, on the y-axis, what we have is the NPV for the entire development. So we're looking at 20, 25 sections, something like that. Again, we have those different development densities on the vertical panels, just like what we were seeing beforehand. Our x-axis is also the same as the proppant loading in pounds per foot. And then what we've added in here, we have different price decks on the kind of horizontal panels. So we have $45 a barrel and $1.75 an MCF, up to $65 a barrel and $2.75 per MCF there. And what we see is that depending on your price deck, the maximization of the NPV across the full unit will vary. So at $45 in this area, a 18 wells per section with 2250 pounds per foot is showing the NPV maximization, although may not be worth the incremental investment, but it's showing the highest there. As we go out to $55 and then $65 a barrel, we start to see two things. Number one, that's drifting towards denser developments as you bring in more and more inventory. And number two, it's pushing you more towards more intense completion designs. So nothing surprising there, but again, it's about finding where the right balance is for you and your circumstances. If I increase the completion designs cost by 30%, let's say we have some cost inflation because oil's $75 a barrel and everybody wants to drill. It actually has a pretty dramatic impact on the value maximization exercise. So definitely pushes you towards the smaller completion design. So we see that maximize NPV at $45 with the high cost at $17.50. And then as we go out to those, higher prices, higher cost environments, still like the inventory, just at a smaller design, completion design. Okay. One other thing I want to bring in here, just as it's kind of, we've been discussing it today, and we, before the webinar, we had some questions about this, but it's how can you bring in the uncertainty to kind of understand how the uncertainty can have an impact on your economics. So what I've done here is actually kind of normalize that NPV by essentially a P10 to P90 ratio, or kind of the total uncertainty spread. I'm happy to put our thoughts on what the best thing to use there is in the chat later. But what this does essentially is it really penalizes, especially those intense designs and those really dense developments. So we see that the maximization goes much more towards more like a 2250 pound per foot design rather than that really intense 2750, which is the model says basically, hey, huge design, dense developments, I don't really know what to do with that. And so that gets reflected in the kind of risk adjusted net present values. Final thing that we want to hit here is explainability. So John called this out as an essential plank of any cube optimization exercise. Really, anytime that you're using advanced analytics, you need to understand how the model is coming up with its forecasts, or how you as an engineer is coming up with forecasts. And what we have here on the x-axis, these are the different variables that the model used to learn how to make its forecast. So this be things like proppant and fluid per foot. We have parent distances, parent days online. We have different spacing metrics like how close are the lateral neighbors or the staggered neighbors, and then we have different geologic parameters like porosity, TOC, water saturation, etc. And each of these bars shows how much that individual feature impacted the model's forecast. And here we're looking at 1 year cumes, and this is all with respect to the average training well here in the Midland Basin. So it's kind of how much does it push it up or push the forecast down. So we see that, hey, yeah, the proppant and fluid loading, this is an intense design. This one is 2750. So this is an individual well that I'm looking at. An intense design is giving you a huge bump here with respect to the average. But that's basically being undone by the tightness of the development. So this is 36 wells per section development. It's very tight. And so it's getting some negative hits there. We are in a good area geologically, so that kind of brings it back up to, still an above average well. But these type of explainability visualizations and data sets to work with are kind of essential. We've found in kind of, you have to go beyond coming up with a reasonable forecast and actually show how the model came up with this forecast to communicate these and actually make decisions on it from management's perspective. So it's an important thing for our customers, and something that we've made sure to kind of cover in our offering, or encourage other people to use. Okay, let me switch gears here. We have kind of one final poll for you. And then we'll kind of move over to questions and answers. So let me go ahead and start that poll. Okay, analytics usage. Okay, so how are you using analytics in your cube planning? Kind of want to know, is this, were the people in the call today, are these active practitioners? Are they analytics curious? Doing some pilot studies, just to get an idea of amongst our attendees what it's looking like. And by the way, after you're answering this poll, put in any questions that you have into the Q&A section. We're happy to go ahead and answer those for you here today, or put in any of your comments in the chat. Okay, so we're getting close to 50% votes there. Let's see, I had a couple more stragglers coming in. Okay, let me go ahead and end that and share the results. Okay, so we see half the people here are kind of piloting it. Some 33% thinking about it. Some people doesn't apply to us, maybe people who are in single zone plays, but are just kind of interested in generally using machine learning for development planning. So glad to have you in the webinar today. And somebody doesn't have any idea what it is. Anyways, thanks for sharing those results. Okay. So at this point, we'd just like to take any kind of questions that you have. Happy to discuss anything that you want to put in the chat. I know that's a lot of material to cram into 55 minutes there. So hopefully we can clarify anything if it wasn't immediately clear. Kieran, do we have anything coming in?
Nothing in the box, but I'll kick off the discussion here. Sure. One thing that really struck me about one of the poll results was the majority of folks said that either data quality or access to data was their most significant impediment using analytics to do cube planning. So how do you think the machine learning approach deals with both of those issues? Because those are as high upstream as you can get right at the start. And if that's where people are feeling the impediment, it seems like there's a lot of potential to unlock value by dealing with those issues.
Yeah, it's a great question, Kieran. It's important to try and get as many wells in as possible. And so trying to clean up your data, trying to bring in data from multiple sources is important. So one thing that we've done is try and make it easy to integrate, like let's say your public data with your own proprietary data or something that you get through data trades, and make sure that those are clean. So that's one thing that's important to do is, within the oil and gas space, is that since we do work with multiple data sources and operators usually only have, kind of a limited amount, that's an important thing to do. The other thing, we do actually have a data sharing network, the Novi data network, where operators can kind of pool their data for model training purposes, but not actually to share the data. So that can be a pretty useful tool, and we're kind of happy to talk with you in some more about that. So I see we have a question coming in here from Richard Sereda. Hope I got that correct. Have we done any case studies on the Montney in Alberta and BC? So we don't have any demo models up there, but we do have a couple of customers who work in it. And this is actually something that they tackle with our software. So, there's cube developments can definitely be done up there, and some people are piloting it or trying it. And of course you want to dial that in. So yeah, it's another great example of kind of a lot of stacked pay there in the Montney, and something that you can go after. One other question that we got, Kieran answered it in the chat about have we used seismic data? Yeah, we've definitely worked with different seismic inversion products. We've worked with kind of basic seismic. We've worked with kind of basic maps of structural depth, thicknesses or things you can get off of seismic, of course. Our software really doesn't kind of care where the subsurface data comes from. It just kind of uses whatever data that you provide to it. So thanks for asking that. Good one. Okay, other questions?
To further continue the theme, looking at our poll results here, it seems like most folks are still in the piloting phase of using, machine learning generally for cube developments. Like, what are you seeing out in the industry, Ted, of kind of maturity of these kind of methods? And we're in a kind of weird place in the industry right now with high prices, but a lot of people don't have the staff to cover that. And so what do you think the importance is of moving that out of the pilot phase? How do we move customers out of, or prospects, if they're going to do it on their own, out of that pilot phase to really using some of these productivity tools?
Yeah, so that's a great question. We have seen some customers kind of go through the full journey where they kind of start to use analytics or machine learning for cube planning, and then kind of it gets further and further along until it's an invaluable tool in their development planning. And the kind of successful behavior that we see is, first they'll start by kind of, all right, well, we're thinking about how many wells we need to put into this zone. So let's go analyze that with the traditional method, and then we'll go analyze it with machine learning. And you'll kind of come up with that comparison. You'll say, well, how much is an exterior well going to produce compared to an interior well? How much is my performance going to change if I stagger it versus I stacked? And you'll kind of do some of those in parallel with the traditional method, and maybe gain some comfort as you see for kind of some of these small targeted questions. We have a lot of alignment between the answers that are coming up with these different methods. The other thing that we've seen, you could do a back test where you try to predict the performance of something, using kind of like a time machine method where you kind of hold it out and have the model predict it, and that can give you a lot of confidence. And then, we even have some customers who've been using our stuff long enough, or other people we've heard about who will kind of predict something before it's even put into the ground. And so that can be another pretty powerful way of doing this. The other thing is that sometimes we'll see customers who will just use kind of machine learning to generate ideas and generate answers. So kind of what does the model actually say is important. You may see some things that are surprising, go run those down. Some of those may be very impactful to your business and your kind of conceptualization of the reservoir. And others, may not pan out. But the ones that do can be pretty important.